Hello everyone, my name is Victoria Patricia Lopez, a doctoral student from the University of Seville, and I'm presenting this research with the title Comparison and Validation of Two Simulation Workflows for Courtyard Microclimates. As an introduction, the research group I belong to has a long background studying the performance of transitional spaces as a passive strategy that helps to reduce the energy consumption and improve thermal comfort in buildings. The current project, named Better, has as one of its objectives the development of a tool that predicts the performance of this kind of spaces. The study of outdoor spaces is gaining attention given their potential to generate microclimates that mitigate the urban heat island effect. Courtyards are a traditional element used as passive strategy to improve comfort in many cultures. Our previous research shows monitoring results with a significant reduction of temperature in courtyards compared to the outdoor temperature. There are many factors that impact the performance of the courtyard. For that reason, it is difficult to predict their performance. Simulation tools that use CFD are needed in order to get accuracy, but it means a lot of computational power and time. There is a very limited number of tools that designers can use during the early design stage to analyze the performance. One such tool is ENVIMET, a widely validated software that uses CFD to simulate microclimates in urban scenarios. It is able to account for the interaction between buildings, vegetation, air, and soil at a wide range of scales. However, the long computational time required makes it difficult to use in the early design. This research aimed to test a hybrid simulation workflow using the Ladybug tools for Grasshopper, previously analyzed by other researchers in the analysis of outdoor spaces. In this case, it is used for the simulation of courtyards, and the results and characteristics of each workflow are compared. The case study selected is located in Seville, a city characterized by hot, dry summer and mild winters. The building selected is a school distributed around an 11 by 7 meter courtyard. The most characteristic element in the courtyard are two palm trees that provide some shadow. The courtyard is monitored during a whole week in summer, between the 4th and the 9th of June, when the weather is hot and dry. Air temperature and humidity are measured inside the courtyard at 1.5 meters above the floor, and a weather station is located on top on the roof of the building to monitor dry bulb temperature, relative humidity, and wind in the outside. Only one representative day, June 8th, is selected for data comparison to simulated results. This slide shows the workflow followed in the two simulations. After the monitoring campaign, the geometry, outdoor wind speed, temperature, and relative humidity are used as input for the simulations. The first workflow consists of the use of ENVIMET, which integrates the simulation of all the independent parameters, providing a huge amount of data at the same time. However, the only data that we use to validate is the temperature inside the courtyard, which is compared to our monitoring data. Some other inputs variables for the ENVIMET are summarized in this table. In the bottom, some images of the process, the model, the simulation screen, and the analysis of the data that also happens in the same software. The second workflow using the Ladybug tool allows to use the geometry model in Rhino, and through the Ladybug plugins, the different parameters are simulated. The climatic file is modified using our monitoring data. Then, the Honeybee plugin simulates the energy performance of the building in order to get the surface temperatures of the courtyard. Then, this data is used as input in the Butterfly plugin, which does the CFD simulation, also taking into account the wind speed monitored before. All these plugins are linked to external software such as Energy Plus, Radiance, or OpenFOAM, but using the interface of Grasshopper, everything is controlled in the Rhino and Grasshopper screen, as you can see in this image. For the CFD simulation, the OpenFOAM steady-state heat transfer solver is used, given the importance of buoyancy in courtyards, where wind speed is not the main parameter and the simulation of temperature is needed. These are the monitoring results for the 8th of June. The maximum outdoor temperature reaches 37.7 degrees Celsius, while in the courtyard it reaches 32.9 degrees Celsius at 1.5 meters above the ground. The maximum thermal delta, which is the difference between the outdoor and the courtyard temperature, is 7.4 degrees at noon. There is also an overheating effect during the early hours of the morning. These are the results provided by the ENVIMET simulation. The software is able to predict the reduction in the temperature inside the courtyard. However, the thermal delta is much smaller, only 2.1 maximum. There is no overheating and the temperature difference is constant during the day. As you can see in the right image, there is no stratification and all the space in the courtyard has more or less the same temperature. In this slide, you can see the Ladybug tool simulation results. The maximum thermal delta using this tool is 2.4 at 2 p.m. It's lower than the monitor delta but is higher than the ENVIMET simulation results. The courtyard temperature curve correlates better with the monitor one. It is able to predict also the overheating that occurs during the night. And as you can see in the right image, with the temperature distribution at 2 p.m., there is also an stratification that is able to be simulated by the software. In this table, we use the coefficient of determination and the root mean square error to numerically compare the two simulations. In general, the outdoor temperature results provided by ENVIMET are more accurate than the hybrid workflow, but the courtyard temperature is more accurate in the hybrid workflow. It was also able to predict the overheating and stratification in the courtyard. Some other advantages are that it is an open source software, which means higher flexibility, transparency, and possibility of optimization. It is faster and easier to implement in the early design, and it uses the 3D interface that the designers are usually use. The main disadvantages is that the evapotranspiration effect of the water and vegetation is not easy to include. In conclusion, this study results shows that the use of the hybrid workflow using the Ladybug tools is valid for the simulation of Courtyard microclimate in hot climates. The proposed workflow is less time-consuming than other CFD tools widely used, and it has better accuracy in the courtyard temperature, and it's easier to implement in the early design. Future research needs to be done to test the workflow in other courtyard configurations and climates. There is also work to do in the enhancement of the accuracy of the simulation and the implementation of some other capabilities such as the evapotranspiration. These are some references uses in this research. Thank you very much.